This is the review video for Chapter 9, Sections 4 and 5 that we're going to be having on our third test. And then we will also have the first two sections of Chapter 10 on this first test. So we're just going to start right into it. The first question says, express the following product as a sum or difference containing only sine or cosine and no products. So what we're going to do is look at what we're given. Cosine of 2 theta times the sine of 3 theta. So we're going to look at this as an alpha and beta, two angles. And if we look in our formula sheet, we'll see that we have the cosine of alpha times the sine of beta can be rewritten using a product to sum formula as follows. We can write this as 1/2. And then we have sine of alpha plus beta minus sine of alpha minus beta. And so next we just need to plug back in alpha and beta in terms of theta. So we'll have 1/2 sine of, let's see, alpha is 2 theta plus beta is 3 theta minus sine of 2 theta minus 3 theta. And so now we'll have 1/2 sine of 5 theta minus sine of minus theta. Okay, but the sine function is an odd function. And so this minus theta, we can replace that with theta and pull the minus sign out, switch that to a plus sign. So we're going to end up with 1/2 sine of 5 theta plus sine of theta. Okay, let's move on to the second problem. This one says use a product to sum formula again. So let's rewrite the angles that we have as alpha and beta again. Here we have cosine of alpha times the cosine of beta. And if you take a look in your formula sheet, you're going to find the product formula for this one. The product to sum formula for this one is what I meant to say. And that should be 1/2. And then we have the cosine of alpha minus beta plus the cosine of alpha plus beta. And if you're not remembering where we're getting these formulas, if you just scroll down to the very bottom of this review, you'll find all of the formulas, right? And so right now we're using our product to sum formulas, so you'd be looking for those. Let's see, where are they? They're on the second page here, right? And so we just barely used this one in this second problem. Okay, and these same 2 pages are available to you when you take the test. Okay, let's continue this problem. What we have is now we need to replace replace alpha and beta with what we were given. So we have cosine of 5 pi over 8 minus pi over 8 plus cosine of 5 pi over 8 plus pi over 8. Okay, let's think about what those are for a minute. 5 pi over 8 minus pi over 8 is going to give us 4 pi over 8, which is the same as cosine of pi over 2. And then the next one is 5 pi over 8 plus pi over 8. 6 pi over 8 is the same as 3 pi over 4. Okay, and we're supposed to evaluate these. Of course, cosine of pi over 2, we know that is going to be 0, right? Because that is the x value. If we look on our unit circle at pi over 2, we're going to get that the x value there is 0 at that point. So we have 0 plus cosine of 3 pi over 4. Now 3 pi over 4, that's in the second quadrant. So we're going to get a negative number there. And the reference angle there is going to be pi over 4. The cosine of pi over 4 is root 2 over 2. So we'll get negative root 2 over 2. And so overall, we're going to have negative, so we're getting 1/2 times negative root 2 over 2. So we're going to get negative root 2 over 2 times 2, or 4. So on that one, we end up with negative root 2 over 4. Okay. The next one says to write the following difference as a product. Okay, so now we're going to be using a difference to product formula. And so we're going to go down to where we have sum or difference to product formulas down here and look for the one that we need. We had cosine of 7 theta minus cosine of 3 theta. And so we're going to be using one. Let's see, I'm looking at the wrong page here. We want sum to product formulas. And we have cosine of an angle minus cosine of another angle. So it looks like we're going to be using this one. Okay, so that's what we're going to be writing and using for this problem. Okay, so we have 7 theta, let's call that alpha. We have 3 theta, we'll call that beta. And then we have cosine of alpha minus cosine of beta. And that is going to be equal to, according to that formula, negative 2 sine of alpha plus beta over 2 sine of alpha minus beta over 2. Okay, so now I'm going to start plugging in my values. And so I'm going to have negative 2 sine of 7 theta plus 3 theta over 2 sine of 7 theta minus 3 theta over 2. And so we have minus 2 sine of, what is that? That's 10 theta over 2, which is going to be 5 theta, times the sine of 4 theta over 2, so that'll be 2 theta. Now we've done what they asked. We're supposed to write that difference as a product, and this is a product. Okay, so we've completed that one. Now we have a similar question. It says evaluate using a sum to product formula. Again, we have cosine of an angle minus cosine of another angle. And so we write down the formula that we need. Cosine of alpha minus cosine of beta is negative 2 sine of alpha plus beta over 2. Sine of alpha minus beta over 2. And that is minus 2 sine of what? We have the sum of alpha plus beta, which is going to be 15 degrees plus 105 degrees over 2. And then we'll have sine of 15 degrees minus 105 degrees over 2. Okay, so now we'll simplify. We have negative 2 sine of, let's see, that's 120 degrees over 2, which is 60 degrees. And then we'll have sine of negative 90 degrees over 2, which is negative 45 degrees. Okay, so now let's compute these two. 60 degrees is in the second quadrant, right? And its reference angle is 30 degrees. Sine is in the, 60 degrees is the first quadrant, and its reference angle is 60 degrees. And the sine of 60 degrees is root 3 over 2. And then the sine of negative 45 degrees, of course, that's the fourth quadrant where the sine is negative. So we'll get negative root 2 over 2. And so I could combine that as, I could have 2, actually cancel these two. I could cancel the minus signs. And I actually have just root 3 times root 2, so root 6 over 2. Okay, and then we'll leave it like that. All right, this next one asks us to verify the given identity. And you'll notice that you have alpha and beta both on top and bottom here. The first one is a sum, and the second one is a sum. The numerator and the denominator are both sums, and they can both be rewritten with a sum to product formula. So that's what we can try here. We can say the left-hand side is equal to what? Sine of alpha plus sine of beta over sine of alpha minus sine of beta. And then if you look at your sum to product formulas, again, you can say the top, or the numerator of that fraction is 2 times the sine of alpha plus beta over 2 times the cosine of alpha minus beta over 2. And the denominator is going to be what? 2 sine of alpha plus beta over 2 times the cosine, I should say sine of alpha minus beta over 2. Got to make sure to write that carefully and correctly. And then cosine of alpha plus beta over 2. Okay, so some stuff cancels here. You have 2, 2, and what else? I guess nothing else really cancels yet, but we can rewrite that as what? Alpha is 2x and beta is 4x, so we could write this as the sine of 6x over 2, so that's going to be sine of 3x, and the cosine of negative 2x, or just negative x, I guess, because we're taking that over 2, so cosine of minus x. And then you have what? Sine of alpha minus beta, so sine of minus x, and then cosine of alpha plus beta over 2, which is going to be cosine of 3x. Now, notice what we're trying to get to here. We're trying to get to minus the tangent of 3x and the cotangent of x. And we're getting close to what we need here. Right here, sine of 3x over cosine of 3x, that's going to be the tangent of 3x. But then I think we need to deal with these minus signs inside of the trig functions before we finish combining. And so let's do that. So we're going to have, in the numerator, the cosine is an even function, so we can just switch this for cosine of x. So we'll have sine of 3x times the cosine of x. But in the denominator, sine is an odd function, and so when we pull that minus sign out, it's going to come out in front here. So I could write that in front of everything and just say minus, and I have sine of x cosine of 3x. And now what I can do here is I can combine the sine and the cosine here and here to get the tangent. So that's going to be, that part will be equal to, I'll have the minus sign still out in front, and then I'll have the tangent of 3x. Then notice what I have left then. Let's see. What I have left is a cosine of x divided by a sine of x, which is a cotangent of x. And so I have the rest of the right-hand side that I needed. So this is equal to the right-hand side, and we have proved that identity.